professor of physics. We don't call it professor at that time, physicist. Unique, totally different. It's a totally different cup of tea, unlike other scientists, because the ideas, concepts that he introduced were out of the box. Nobody could think that things can happen like this. He developed special theory of relativity all alone, then general theory of relativity after 10 years, for which he is famous all the time. But he did not get Nobel Prize for that. He got Nobel Prize for another contribution, photoelectric effect, and that is a quantum effect, which he explained in a very beautiful way in a one-page paper, for which he got the Nobel Prize in physics. Now, but he is more famous for relativity because that is the field for which, because of which we know so many things about this universe. Now, what he did, he worked for 15 years at a stretch to develop general theory of relativity. About special theory of relativity, most of you are aware, but still I would like to tell you some of the most interesting concepts. Why special theory of relativity so exciting? Because this theory gives you a totally different concept about space and time, especially about time. For the first time, Einstein proved that time is not absolute. Time is not objective. Time is highly subjective. It depends on motion. It depends on where you are. What is your speed? Now that was something very strange. Till then people thought 1 hour is 1 hour for everybody, whether you are at rest or in motion. But he said, no, it depends on where you are and what is your motion. If you are moving faster, time will run slow. If you are moving slower, at rest, time will run faster. Can you imagine? Now you see then, I still remember in one seminar when Einstein was proposing all these things, they were, Sir, Professor Einstein, what do you say like that? Can you give us some example? The time can run faster, it can run slower. Then he made a joking reply. Einstein used to make very beautiful statements. He said, okay, gentlemen, you are a young man, you know what is love. If you have a girlfriend, and suppose you are expecting your girlfriend, and you're waiting, and it is delayed, and it seems as if time is running very slow. She is not coming, time is running slow. But as soon as she comes and meets you, you have a nice time together, they don't know how time passes. It passes quickly. This is our experience. So this happens not only in our experience, even in real physical measurements. That is the greatness. So he used to do. Now, this is the special relativity part. Then general theory of relativity, actually it is a relativistic theory of gravitation, a new theory of gravitation which replaced Newtonian theory of gravitation. In this theory of gravitation, it doesn't bring in any concept of force. It simply says that, no, gravity is simply caused by matter and space. Our space and time is like a fabric, it's a membrane. So that if a mass happens to be somewhere, there's a dip, there will be a dip created at a particular place. The surrounding area, the space will be carved. And any smaller object coming to that region cannot pass that, it will start moving about that object. This is a new concept and experimentally verified also. I cannot go into details because, as I told you, many technical things I will have to tell you about. That is not my object. I just want to share the flavor of what he said. This is the new idea. Gravity is caused by curvature of space and time. And there comes a statement that matter dictates how the space should curve. And in turn, space dictates how matter should move. Interrelated. So, according to him, gravitation is simply created by space, curvature of space, nothing else. Now, this has been verified remember, whatever predictions have been made by general theory of relativity are being verified one by one, even till now. You must have read recently the discovery of gravitational waves because of collision of black holes and all that in space. This was long time predicted by Einstein 100 years back, and it was just experimentally verified existence of gravitational waves in 2015, 2016, for which Nobel Prize were awarded. So that is Einstein. Now Einstein theory also says, general theory of relativity, that gravity, not only motion, gravity also affects time. If you are in a place where gravity is very strong, time will run slower compared to a place where gravity is weak. For example, suppose someone is living in Jupiter. Jupiter is a much heavier, higher gravity. So two persons, imagine that one is living on Earth, the other is living on the Jupiter. Then the man on the Jupiter, on the average, will live 15 minutes longer than the man on the Earth. This is the effect of gravity. This is another very wonderful prediction from the theory, and it has been verified in number of ways, various ways, using atomic clocks and all that. And do you know, nowadays we are using GPS system for location finding. This GPS system, they have atomic clocks synchronized with the clocks at the Earth. Satellites are there, they carry clocks, and these clocks must be synchronized. And this synchronization needs relativistic corrections. You must take into account of the gravity effect and the motion, how much time must be adjusted. And accordingly, in the satellites, before they send the clocks, atomic clocks, on the Earth, they synchronize that, for example, 5 seconds or 2 seconds must be ahead or like that. This is done. And then only we can use the GPS correctly. Suppose this is not done. You simply take the same clock without synchronizing to this. Then, when you use GPS, what will happen, Suppose the GPS is showing that this is the place you are arriving at. You want to get down, you see that, no, this is not the place, it is 10 kilometers away. Wrong information. Wrong information about direction and time. But that is not happening now. It is because Einstein's concepts of time dilation, all these things are being used. You see, these are applications, so important applications. Now, not only that, Einstein, when he developed the famous equation of this general theory of relativity, it's a complicated equations, when it was first solved, it was found that it explains everything about this universe. Most important is that the solutions of this equation predict that our universe cannot be static. It is either expanding or contracting. Two possible solutions. Einstein was in a puzzle. He wanted to change some quantities in the equation, but later on he removed it because it was a very difficult period for him and scientists. That what is this happening? Newton said universe is static, but here suddenly Einstein equations say it is expanding, highly dynamic. That was in 1915-16. After 5 years, 1920 up to 1929, another golden period of cosmology. All of you must have heard about Edwin Hubble, the famous astronomer. He was looking into the sky, deeper into the space, with big, big telescopes, very powerful, 200, 300 inch diameter lens. He could look deeper and deeper throughout the space. And what he discovered over so many years, his group discovered that our galaxies are not stationary. All the galaxies are moving away from one another at a very high speed. Nothing is at rest. This means that everything is going away from each other. Everything is moving away from each other, galaxies, galaxies. Now, is it not expansion of the universe? So this supported Einstein's prediction that our universe is expanding. Universe means what? This collection of galaxies. Galaxies expanding means the entire universe is expanding because moving away from each other. Now this was one of the revolutionary discovery of that century. Now it is 21st, it's all time. Now people were puzzled, lot of thinking was done, people repeated the experiments, same thing happened. Now when same thing happens experimentally all the time, you have to believe the truth. It is true. It is true. Now if it is true, what is the consequence then? Consequence is still very strange. Now if the galaxies are moving away from each other at the present moment, what was the situation, say 10,000 years back? They must have been closer to a galaxies. Again go back in time. You can go, keep continuing going back. Again closer, closer. Then a time will come when all the galaxies must have been closer together. All the matters, energy in this universe must have been concentrated at some single spot if this expansion is correct. Because now it is moving away. So long past, somewhere, all this matter, energy must have been concentrated in some form somewhere. This means something very interesting. That is, our universe at the date of birth. It was created, it had a beginning. Now when the question of creation comes, the question of beginning comes, then next question is, what or who created this? Newton avoided this question because he did not want to bring the concept of God and Creator. But now, unwittingly, this situation is different now. That something was created. The universe was created. I don't know how, we don't know, but it was created. It is a reality. But this story is correct. All the results have been verified experimentally. The Big Bang theory has been proposed. The predictions of Big Bang theory have been verified experimentally. And now I believe that this is the truth. Our universe is expanding. It had a beginning. But how was it created? That is the next question. The creation is, you cannot explain by classical physics. Here quantum mechanics comes. You see, we talk about Professor Wheeler. He said that if you talk about God, there are two types of God. Classical God and quantum God. Classical God, visible, everything. But quantum God is something, you see, you don't observe what he is doing. His creations are not observable, but effects are observable. And quantum God is governed by quantum mechanics, laws of quantum mechanics. And laws of quantum mechanics, quantum mechanics something I cannot now go into this. Quantum mechanics, simply I will say, quantum mechanics is mysterious, magical, mystical, metaphysical, and mind-blowing. Your mind will go wrong. Let me tell you one thing, my own experience. When I was studying MSc Physics in Delhi University, we were taught by some very distinguished theoretical physicists, D.S. Kothari, Professor Mazumdar, and Mitra, very internationally known physicists. I had special papers, advanced quantum mechanics, and I was so excited what was happening. And I got completely seduced by quantum mechanics. And I fell in love in quantum mechanics, which is still continuing. See, once you try to learn what is quantum mechanics, seriously and sincerely, you will fall in love. And you will live and study more and more, know more and more, and it will be a permanent bonding. I don't know. It happens with many people, not only many theoretical physicists, they become, at the end, many Nobel Prize winners, all quantum philosophy, everything they talk about. I am not going to into this. So, quantum mechanics, why? Let me tell you. Quantum mechanics says that we go deeper and deeper into matter. Atom, everybody knows, but quantum mechanics tells you what is there inside atom, okay, and what is happening, how electron is moving around the nucleus. This motion only quantum mechanics can explain. Then not only that, you can go inside the nucleus and see protons, neutrons are there. Even within proton you can go, within neutron, and we find that there are more particles inside a proton and neutron called quarks. So ultimately, our understanding is that quarks, most fundamental. Fundamental means they cannot be further divided. Electrons cannot be further divided. So these are some fundamental particles. Till now, we say that there are 17 fundamental particles in this universe. 6 quarks, 6 leptons, and 5 they are called bosons, photons, gluons, and all that. And these 6 quarks and 6 leptons, they are responsible for constitution of matter. But when you want to constitute matter from particles, you need some cementing, bonding. How does this bonding occur? This bonding is caused by bosons, we call it. So photons, gluons, there are so many such particles, and WZ particles, everything is there. I do not go into details. So bosons is a new class of particles, 5. So only 17 particles are needed for this construction or building this entire universe. 17 fundamental particles, nothing more. This is one of the greatest discovery from theoretical physics. Greatest discovery. So the question was, if this is the case, now coming back, if the universe had a beginning, at the beginning these particles must have been created. Because out of these particles, everything was constituted over billions and billions of years. But by the way, our universe is now 14 billion years old. 1400 crores of years old. How you know it? I mean, you can easily know it looking at the most distant galaxies that you observe. It is 14 billion light years away. Today what we see, when you say 14 billion years old, we mean that the most distant galaxy that you observe, it is 14 billion light years away. That is, we are now receiving the light from there, which started from there 14 billion years back. Now we are receiving it. So since that is 14 billion years back, we say that that is the limit of observable universe as of now. But another 100 years, we may go even deeper. Remember, nobody can observe the present. Nobody can look at the present. How do you look? How do you see? It is because of light. Light must come from the object and fall on your eyes or telescope, then you observe. But light has a finite speed, c equal to 3 into 10 to the power 8 meter per second. So light takes time. So even if I say that I am looking at you, I look in your past. I see your past only because light is taking time. So this is the concept in physics. So this 14 billion years old, that is now I am receiving. That is how we say our observable universe is 14 billion years old. Now, in that case, what caused this universe? What is responsible for this creation of this universe? we cannot understand this without quantum mechanics and theory of relativity. If you combine quantum mechanics and special theory of relativity, a very wonderful theory is obtained. It is called quantum field theory, developed around 1940. Dirac was the pioneer in this field. And once quantum field theory was developed, new things came up, new concepts came up. The most important concept that came out of quantum field theory is concept of vacuum. Now, why vacuum? Ordinarily, we mean that vacuum is where nothing exists. Vacuum is where nothing exists. But in quantum field theory, vacuum appears as it is where nothing is observable. See, look at the difference. Nothing exists and nothing is observable. Whatever device you have, whatever sophisticated instruments you have, experiments, it cannot observe anything, and that is the vacuum in quantum mechanics. It is called quantum vacuum. But this quantum vacuum, according to quantum mechanics, under certain conditions, can be visible. Fluctuations may be there suddenly. It is like, let me give an example. Suppose you consider an ocean, calm water, calm and quiet surface. So you see from above, it's nothing is there, okay? Just a sheet. But then suppose some waves are created because of disturbances. There are big waves coming up. Then we say, oh, what is going on? Waves coming down, coming up. This happens in vacuum, quantum vacuum. If somehow some disturbance is created, suddenly vacuum becomes excited, fluctuations occur, and these fluctuations are very, very organized. Excitations. This excitations is a form of energy, and these excitations appear as particles, antiparticles, pairs of antiparticles. So, according to quantum theory, vacuum can create pairs of particles, antiparticles constantly, but these are virtual pairs. Virtual in the sense that you cannot observe them. But only under very special conditions, one of the pair can be observed under special conditions, and this has been done also. But anyway, this is the concept of quantum. Now, once this quantum vacuum was introduced, people tried to explain the origin of the universe in terms of quantum vacuum. Professor Alan Gart, he is very famous for what is known as inflationary theory of the universe. That is needed. Beautiful theory, very exciting theory. He proposed that in the beginning, neither here nor there, neither now nor then. That is no concept of space and time. Nothing. So you cannot ask the question, what was there before the Big Bang or before the creation of the universe? Because that question is meaningless. But when you ask before the creation, you are bringing time. But time did not exist. You can ask questions only after the creation. When, how, like this. So, he said that, it's a beautiful theory accepted by the majority of the physicists now, that somehow the quantum vacuum always existed, unobservable. Suddenly, what happened? Nobody knows. Something happened. There's a situation in quantum vacuum. Suddenly, quantum vacuum was in a higher energy level, excitation, but it cannot be a stable state. So it makes a transition to a lower energy stable state. And in the process, when the vacuum comes down from higher energy level to lower energy level, tremendous amount of energy is released. That happened in the beginning. But this energy is so tremendous, powerful, that everything expanded or inflated. The original size inflated up to 10 to the power 26 times within a period of 10 to the power minus 32 seconds. Imagine. Now, once this inflation occurred, over time, it cooled down. Temperature was very high, tremendous energy. Over time, cooling effect is there. As expansion occurs, cooling effect occurs. So, after cooling, condensation of vacuum started. Condensation. For example, in winter, vapor, atmosphere condense into drops of, dews on the leaves you see, on the window panes you see. It is something like that. Condensation of energy, and they appeared as quarks, leptons and all that. But this is the theory, remember. But how they were created, why, nobody has an answer. But this is the possible theory that we can propose. They were created, and rest is history. All these fundamental particles were created. Over time, quarks combine to form proton, neutron, okay? Then proton, neutron combined to form nuclei. Electrons were left because still atoms are not formed. Because the particles were moving so fast, no stability. Electron could not come near the nucleus. But over time, when further cooling was there, electrons were attracted to nucleus, atoms were formed. Atoms were formed for the first time, when? About 4 lakh years after this initial condition, after the birth of this inflation. So like that, when atoms, molecules are formed, rest is history, and this galaxy, nebulae were formed, out of nebulae star was formed, and galaxies, and ultimately we have this beautiful universe. So you see, and out of this beautiful universe, we have our wonderful art. So the art origin, the creation of origin of art is at the quantum vacuum, if you go back in time. So that is a miracle. Now, these questions, when you talk about quantum vacuum and this creation history, it brings about a lot of philosophical, metaphysical questions. I don't go into details, I will just share some of the ideas, okay, from the physicist, well-known physicist. And you see, even Newton later on, when he could not explain this origin of this force and why the planets are moving around, okay, somebody asked Newton, why billions of years the planets are moving in such a stable position, nothing is happening, no catastrophe, stability is there. Then he said, what he said, you see, this most beautiful system of the sun, the planets and the comets could only proceed from the counsel and dominion of an intelligent and powerful being. B is the capital letter, powerful being. It doesn't call it God. Because scientists, physicists, they are a bit allergic to the word God. They replace it by superior being, intelligent, super intelligence, all these beautiful words they use. But remember, what we mean by God, that is in a very narrow sense, but this is in a wider sense. We don't know God exists or not. Nobody knows. But what physics has revealed is that there is somewhere an intelligence, super intellect behind all this organization. Everything is so well organized, finely tuned, finely balanced. Only intelligence can do it. That is called cosmic intelligence. Cosmic intelligence, whatever name you give it to it, God, Creator, whatever it is. But we believe in cosmic intelligence. Intelligence creates intelligence. Cosmic intelligence created biological intelligence in us. Biological intelligence, animals, human beings. And now we are so intelligent, human beings, we can now create artificial intelligence, robotics. Is it not interesting? Is it not miracle? Intelligence, intelligence, intelligence. And we do not know what is in the future. And what this artificial intelligence creates, we are already using everywhere artificial intelligence. Remote control, TV, even smartphone, everywhere artificial intelligence. Just you use your, I say you already you know now. It's all artificial intelligence, sensors and all things coming in. So remember, this is artificial intelligence created by biological intelligence like us, and we then, who created us then? We say cosmic intelligence. What is that cosmic intelligence? It is for you to interpret, to think about. God has no name. God has no name. Who gave this word God? But in Indian philosophy, you can give the name. There's a meaning of God, I will tell you. Then next, let me tell you, Einstein, you are so overwhelmed. He said once, he was asked by a reporter, Professor Einstein, do you believe in religion? He said, I want to know how God created the universe. He used the word God. I wanted to know how God created this universe. Then he suddenly said, he should not say God. God suddenly, the word came out of his mind. Then he again corrected. He said that it is like this. My religion consists of the humble admiration of the limitless superior spirit who reveals himself in the slight details we are able to perceive with our frail and feeble mind. See, he accepts the existence of a supreme intelligence, indirectly God. Now Dirac, one of the most, famous theoretical physicists, very famous, he was an atheist. But he discovered the most powerful equation in quantum mechanics, Dirac equation. So when Dirac and few of his friends, all Nobel Prize winners, they were discussing about religion and God. Then Dirac said, oh, God. Then Pauli, another physicist, he remarked, see, our friend Dirac, he does not believe in God, but he believes that he is the prophet of God. Prophet of God. Because he says that mathematics is beautiful. Our universe is only mathematics, because he produced that famous equation, mathematical equation. So this was joking, he said. But remember one thing, that ultimately we agree that even if there is some creator, whatever it may be, he or she, must be the greatest mathematician and physicist and scientist, because without mathematics, proper equations, you can never understand anything. Whether it is biology, chemistry, everywhere, it is essential. Only degree differs. In theoretical physics, we use maximum mathematics. And that is we say, that is the cosmic code. The only language that nature understands, it is mathematics. You write a simple equation, famous equation, which we cannot, but the genius, we can write. A simple equation can express so many things about this universe, particle or nature, that you will be really wondering, how is it? Then, you say, another very famous cosmologist, Robert Jastrow, then Roger Penrose. Let me come to Roger Penrose. He got Nobel Prize in Physics. He was a colleague of Stephen Hawking. Now, what he said, you see, he compares, let me give you. He says, suppose all the laws of nature you put in a glass, like wine. All the laws of nature are put in a glass. Now he says, the first gulp from the glass of natural sciences will make you an atheist. Because as you look into the glass, natural laws, you see everything is explained. Everything we know. So, no role of God. God is not necessary. Then he said, but at the bottom of the glass, as you come to the bottom of the glass, God is waiting to receive you. What does it mean? Beginning of creation. You here, but go to the origin. What is there? So this is some of the reactions given by them. Then another very famous physicist, Professor R.P. Feynman. Once he met a friend, not from physics. They were just talking about, they were drinking together and discussing. Then his friend, Feynman's friend, asked him, "Oh, Professor Feynman, tell me, these poets are mad. These poets, they talk nonsense." He said, "What nonsense they say?" See, one poet has written somewhere that the entire world is in a glass of wine. Is it not nonsense? How can the entire world can be a glass of wine? R.P. Feynman says, no. It's not a joke. He's telling the truth. The friend was astonished. Truth? Why? Okay, let me explain to you. Look at the glass carefully. What is glass? Glass, chemistry, physics involved. Then look inside, liquid. Again, physics, chemistry comes. Color of the wine, again physics. And fermentation, how this wine is made, biology. So, physics, chemistry, biology is put into a wine of glass. If you understand this wine of glass perfectly, you have to use physics, chemistry, biology. What is this universe? What is this world? Nothing but physics, chemistry, and biology. So he is correct. Your world is in a glass of wine. Thing is that what is your attitude, how you try to explain it, that matters. So poets also speak the truth sometimes. Then, you see, now I am coming to just 2 more minutes. You see, about this creation history, that is, now we say everything was created out of nothing, quantum mechanics. Now this has a philosophical implication, and if you look at the Indian philosophical thinking, Vedic thoughts, you find some parallel there. Let me give you an example. You see, in the Vedic thought, if you know, there is a famous sentence in Vedas. See, when the English translation I am giving you, when the dark nothingness reverberates, and takes form, physical existence begins. But according to Vedic thought, this physical universe was created out of nothing, darkness, nothing. That is just agrees with the modern quantum concept of vacuum. Now Shiva, Mahadev, you know, Shiva. Shiva is called Devadidev Mahadev. You know Shiva, meaning of Shiva. Shiva means nothing. Nothing means nothing. Shiva is nothingness. But he is the most powerful God within. So this nothingness, what is called quantum vacuum, is the most powerful of all things, because that is the origin of all creations. And that is why people are now working to understand more and more about this nothingness. We say, if you ask a top theoretical physicist what you are doing, he will say, I am trying to understand nothingness. The ordinary people will understand what is nothingness, is not doing anything. Studying nothingness means quantum vacuum. So these things are happening now. Some of the things I wanted to share with you. But you know, this is a very long field, lot of things are required, and I don't know how much I have told you, but I always prefer to speak using blackboard and chalk to explain more things in a better way to the people who try to understand. But you have a mixed audience, so I am a bit challenged, and I have tried my the way I can, small things, some flavor. Only some flavor I have tried to give it to you. So now, what we see is that ultimately, what is God? That is for you to interpret. We have introduced you to some of the most exciting concepts going on at present. Now, see, now the physicists, philosophers, they are coming together. And now they are taking to a higher level. From this quantum vacuum, they are coming to consciousness. What is consciousness? Why I am conscious? What is the meaning of life? Ultimately, answer is here. You know what is consciousness? Consciousness is part and parcel of a living thing. You can feel, you can have emotions only if you are having consciousness. What is the origin of this consciousness? That is the question people are trying to understand, and most of it, physics has, now it has, it has started now asking questions and trying to answer many things. Even I have seen papers on theory of ghosts, ghost spirits. So anyway, thank you so much for your patience. I have taken a lot of time, and thank you so much.
Thank you, sir, for such an interesting, educative and engaging lecture session. It was indeed a privilege to listen to you today. Now we would like to have a Q&A session with Professor Rajput, sir.
Any questions?
Sir, just I want to ask one question. Not question, this is a query.
Yes, please.
Sir, we know about the 3 degree background radiation. Is it the evidence of Big Bang?
Phosphate microwave background. Can I speak like this?
Okay, sir.
You see what happened? I give you a simple example. You crack a bomb, okay? Energy, everything is liberated, right? So, suppose this happens within a closed room. Closed room. You bomb is exploding, and you close the room. Go away. Okay. Now, after a few days or months, suppose the room is completely closed. You enter. You'll find some smell. Okay? But this is not the present smell. It was long created. Cosmic background, microwave background is like this. When this explosion occurs, Big Bang, after 300 and after 3 lakhs years after the Big Bang, when energy was released, radiations, photons and all that, it already exists throughout the universe as a background. The earliest relics exist. It's uniformly distributed throughout the universe. But this could not be detected till 1962. Pangeas and this, they first detected as a microwave. Constantly from all directions. They were, in the beginning, they were surprised where from it is coming. They thought maybe some wrong signals from somewhere. Then they repeatedly rotated this detector in different directions. Still, same type. Then they studied it. And they found that it is in the microwave region corresponding to 3 degree Kelvin. Then they said that the origin of this must be the universe, connected with the universe, and you call it the background radiation. And further it was verified by experiment in 1999, Kobe, famous Kobe experiment, using satellites and all that. That you already know. So now it is a fact that something happened like this, and this radiation, background radiation, spreads throughout the world. That is one proof that the universe was created.
Sir, the word symmetry.
Huh?
Symmetry, the word symmetry, is it a classical concept or quantum mechanical concept?
It's not only a scientific concept, it's a universal concept. You look at a flower, petals, you see it's so symmetrical. You need not be a scientist for that. Anybody can look at it, symmetrically arranged. This is the ordinary concept of symmetry. Okay? Now, if you go a bit higher, mathematics and physics, sphere. You look from any angle, anywhere, all the points are identical. Rotate it, again a sphere. Same shape. This is called geometrical symmetry. So this concept developed in physics slowly. Can you have some higher symmetry? And physicists found, yes, there is some higher symmetry. It is called dynamical symmetry. It's mathematical. For example, in quantum mechanics, you can prove that. See, let me tell you one thing. In physics, we are familiar with famous laws of conservation. Laws of conservation of energy, laws of conservation of momentum, linear momentum, angular momentum. But in classical physics, you cannot prove this. It is like an assumption. Because we say energy can neither be created nor violated or destroyed, so it is conserved. That's all. But quantum mechanics has an answer in terms of symmetry. Quantum mechanics says that this conservation law of energy is an outcome of a dynamical symmetry, space symmetry. That is, it is something like this, isotropy. Isotropy, we call it isotropy, isotropy of space. Space is homogeneous and isotropy. Isotropy means, just suppose this, whether you say, suppose you rotate a thing, okay? Around this space is symmetric with respect to that. There is no special position in the space. Now, if that is the case, you can put the sphere here or sphere here, it is same sphere. Now, this means if you translate or rotate, suppose you rotate the system, it is isotropic with respect to space, and this has a mathematical consequence that momentum is conserved. I am telling you conservation of momentum. Conservation of energy follows that if this sphere is also symmetric with respect to time, that is, suppose you look at this sphere today, then tomorrow or day after, the same thing. It is called symmetric with respect to time translation. Whatever be the time, it remains the same. So that has a consequence that total energy is conserved. Total energy of that. Mathematically proved. It's like that. And similarly, angular momentum, everything can be proved. Then we now talk about Gauss symmetry. You see, this higher physics, chromodynamics, quantum chromodynamics and everything, they are the consequences of another very high mathematical symmetry. We call it Gauss symmetry. Gauss symmetry. See, these things only physicists can understand, and some theoretical physicists with this. So this symmetry is a very, very... Now remember, when you talk about symmetry, interesting point. This creation started with symmetry, highest symmetry. But these beautiful creatures have been possible because at every stage, symmetry was broken somewhere. So we now say that symmetry must be broken somehow to create something new. Let me tell you, suppose you have a metal, sphere metal, okay, highly symmetric, but you want to create an idol out of this, beautiful idol. what? You have to describe it. You have to describe a symmetry. It is no longer a sphere. But you have a beautiful form. Beautiful object. So form can be created only by breaking symmetry. Everywhere symmetry. You know conductors. Ordinary conductors. What is superconductor? Superconductor is a result of symmetry breaking. You can prove it. Ferromagnetism is an example of symmetry breaking.
So is it,
All these things.
is it spontaneous symmetry breaking?
Huh?
Is it spontaneous symmetry breaking?
Spontaneous. But don't ask me who or what did it. We don't have an answer. We only explain like this, and this is understood. Symmetry breaking is very essential. You are a beautiful young man. Why? Symmetry is lost. This sculptor, they create beauty by breaking symmetry of the stones. It's like that. But who is the ultimate sculptor? We don't know. Designer. That's it. It happens. Beautiful. Very exciting things. It will take you to a different level. Who knows? But now the question is, I'll put you a question before you. If you assume that God exists, what should be like God? Have any one of you seen God somewhere? There are so many religions, temples, churches, mosques. Have anyone claim that I have seen God today? That is, we say God exists but invisible. Invisible. Why? Now physics has an answer. We say that if God really exists, God must live in a multi-dimensional space. You say dimension is very important. 1 dimension, straight line, 2 dimension surface, and 3 dimension our this usual space. We are all 3-dimensional human beings. Everything in this universe are 3-dimensional. Plus time. Time was introduced by Einstein as another dimension. So it is a 4-dimensional space. Because without time we cannot exist. So this see the Einstein greatness. He said only space is not sufficient. If you don't bring time, life cannot exist. Time is, I can tell you, see, time is so interesting. If I want to tell you about time, there will be not enough time. That is the mystery of time. And time, you can show that we exist, life exists because of time, and time exists because of motion. Nothing else. So, now, God, see, multidimensional, I'll tell you, give you an example. We are, you see, suppose just assume this 2-dimensional blackboard. Say that is a universe, 2-dimensional universe. And suppose that there are some creatures there, intelligent beings. They are all 2-dimensionals. Only length and breadth. No height. They know only that surface. Now, I stand before that. I am 3-dimensional. They cannot see me. Because they do not have the concept of 3 dimensions. They cannot, but I can see them. So from a higher dimension, you can always look at the lower, but not the other way. So if God exists, it must be at a dimension higher than 4 or higher. So God can look upon everything, but we cannot expect to see Him. This is another example. Then, God is everywhere. Why? We say God is everywhere. It's correct, if there is God. You know, there are 3 constants in this universe: speed of light c, Planck's constant h, gravitational constants capital Z. These are 3 constants. over the billions of years, their values have not changed. And this, because of this constant values fine-tuning, everything exists. Because Planck's constant exists, atom exists. And this C, constant speed, it exists because the universe exists, radiations. And without, if C, value of C changes somehow by small amount, even atom will collapse, nothing will happen. So we now say jokingly that C, H and Z, and Z, gravitational constant, if there is a slight change in Z, value of Z, the whole solar system will collapse. Nothing will remain. So we say that this CHZ is the Trinity of God, three gods. They control the entire universe, Brahma, Vishnu, Maheshwar. We call it. I'm joking. And someone said that God, the name is borrowed from Brahma, Vishnu, Maheshwar. Z means generates, O means operates, D means destroys. Brahma, Vishnu, Maheshwar. So these are some things we discuss sometimes. So this, we can think of, if somebody wants to know what is God, then we have to think like this only. Never expect God to appear before you. Why? Another example. Why? If you demand, you do an agitation, if God, you stay here, come and so, come. God will say, do you want to destroy the universe? Because if God happens to be here, he will be a three-dimensional object, he or she, whatever it is. Once God becomes a part of this universe, God must follow the laws of nature. One who creates the laws cannot violate the laws. It's constitution. So God will say, if I happen to come, I will have to die. If I die, what will happen to this universe? Do you want me to die? Don't expect God to come. So be satisfied that God you do not see. This is a blessing for us. Professor Narahari, am I right? See, this happens. So these are some of the interesting things. And God is everywhere. Why? We said, from relativity, in Einstein, I have to go to Einstein. Einstein is one of the greatest. He was a romantic physicist. You know the meaning of romantic physicist? He gave equal importance to love, music, and physics. Once he said, jokingly to his friend, you are driving a car, and if you are while driving, you are kissing your girlfriend, you are doing injustice to kissing. Why? It has a very wonderful meaning. Concentrate only in one thing at a time. If you want to achieve something, simultaneous driving and doing something else, nothing will come out. So anyway, it's a highly romantic, he used to say like this. But anyway, speed of light, you say. Speed of light. Einstein told us that this is the maximum speed, and if someone moves at the speed of light, time stops. Time stops. You are young. And you will be everywhere. Because if suppose assume that you are a photon, then for you, everything appears simultaneously everywhere. God is everywhere. So if God is there, speed at sea all the time. Exists with sea. So you cannot hold it back. You cannot hold a photon and bring it back. Impossible. So these are some of the ideas that we have found out from theoretical physics. It's very interesting, and I request all of you, if you are interested, you go into this. These are so many good books also, but they discuss these things in a different way. But I feel that even Professor Davis, one very famous theoretical physicist, he once wrote in a book that if you want to go to God, don't go to any temples, church, or whatever it is. go through physics, study physics, science, and that will lead your path to the ultimate. And there you sit and discuss. This is some of the, even recently I read one very famous book by Carlo Rovelli, Italian theoretical physicist. He was working on quantum gravity. You know what he said? I was surprised. In the beginning of the chapter, he was talking about this universe flowing everywhere, motion. He said, is it not dancing Shiva of Indian philosophy? Shiva dancing, as if the universe is dancing all the time. So what a beautiful analogy he said. Indians already discuss about the dance of Shiva, you know, Nataraj. So these are some of the ideas. Now these physicists, most of these, they are trying to learn these Indian ideas, philosophy, and they find some parallelism, some parallel between these ideas, maybe in a different way, but some sort of thinking. Remember, we are all human beings, whether you are a scientist, or a philosopher, or a rishi, whatever it is. Brain. Everyone has a brain. How that brain thinks makes you a scientist, or a philosopher, or an artist. After all, it's the brain. So, whether it is the artist, or a poet, or a philosopher, truth may be spoken sometimes. Ultimate truth. Okay, thank you.
Thank you, sir. Sir, due to time constraints, the audience may post, if the audience have any questions, then they may mail to Professor Rajput, sir, address. So with this, we have come to the end of today's program. Now, I would like to call upon Dr. Shantanu Borua, convener of today's event, to deliver the vote of thanks.
Exciting piece of story. We all have to realize that classical mechanics is built on deterministic theory, where it is based on the laws. Simply put, Newton's laws of motion, and then Gibbs. There are many other formulations that are there, and the most famous is Lagrange and Hamilton's formulations. Then we went to quantum mechanics, which started with second order differential equations or matrices or path integrals. Einstein is a funny character in quantum mechanics. When in 1905, in 1 year, sitting in attack, he tried to describe 3 theories. One is for the small photoelectric theory. Reluctantly, he put forward the concept of quantum. Then he has the big, that is theory of relativity, and then the complex, Brownian motion. So for all these things he did in 1905, that's why 2005 we celebrated as the year of physics. He was constantly at fight with all the galaxy of people who are propagating quantum mechanics. The famous Solvay conference, where Niels Bohr and his company comes and then try to convince Einstein every day that quantum mechanics is real. Einstein says that the famous sentence that God doesn't play dice. He doesn't believe, but he will not be able to put up with the fight with this, and eventually he gave up. And there are pioneering contributions like Rajput said, quantum macrodynamics, and the Hubble's discovery really, where there is a huge problem to look at the expanding, the singularity concept that is there, and still this Hawking's radiation, although there is background radiation, there are still lots of mathematical issues that remain, where we have the energy matter equivalent, E is equal to mc squared, and then the energy can be produced from matter is also very important, the boson concept. These are quite interesting, and then people have to really look at science in its own way, and the rigor in mathematics, rigor in language is extremely important. And India is losing it because we are giving up in mathematics. many of the, because these young fellows are there. Thank you very much for staying, these students. So India was famous because it discovered zero. That's trivializing things. I just wanted to do the Shanti Mantra. I'm not very good in remembering things. But all of you have Shanti Mantra, you know, Sahana Avatu, Sahana Bhunaktu, but there is another Shanti Mantra which is actually talking about zero. Om Purnamada Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Visishyate. This is the origin for zero. Purnamada Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Visishyate. What does it mean? Om, that is complete. This is complete. From the completeness comes the completeness. If completeness is taken away from the completeness, only completeness remains. Om Shanti Shanti Shanti. This is one of the Shanti Mantra. I try to understand it. I don't understand it. Somebody said that if you confront quantum mechanics, if you say that you understand quantum mechanics, there are only two possibilities. The first possibility is you are lying. The second possibility is you don't understand. Thank you.
Good evening. Honorable Director of CSIR-NEIST, Dr. G. Sastry, Chief Guest Professor Amadou Rajput, Professor Jorhat, Guest of Honor, Professor Horst Gupta, Special Guest, and all other distinguished delegates and my fellow colleagues and students. I feel highly privileged being the convener of this event to propose a vote of thanks of the Art Day celebration at CSIR-NEIST Jorhat. First of all, aligning with the mission of the Art Day initiative, I would like to solemnly pledge to further my efforts towards promoting earthquake awareness program in Northeast India. In fact, this is a small initiative towards earthquake awareness program under the leadership of our Honorable Director, Dr. G. Sastry, and the watchful eye of Professor S.K. Gupta and Professor Jorhat. My first word of profound acknowledgement and thankfulness is reserved for our esteemed Director, Dr. G. Sastry. I believe he is one of the finest ambassadors of this global mission to protect and restore the earth and its environment from the natural calamities. Under his able leadership, today's event has been recognized internationally by ArtDay.org, the official franchise of this global mission. Sir, thank you for your perennial encouragement and assistance. Without your holistic guidance, this event would not have seen the light of the day. I would like to thank Professor Amadou Rajput sir for his lucid and eloquent talk on the interesting topic titled The Creation of the Planet Earth as a Cosmic Miracle. We have learned the concept of God through physics, study of earthquake in terms of quantum mechanics, maybe future scope of studies in near future. It is also important to know about the mechanism of earth formation before earthquake hazard. Thank you, Professor Rajput, for the highly illuminating session we have today. I would also like to thank galaxy of luminaries we have with us today, Padma Shri Professor S.K. Gupta and Professor Jorhat. I am thankful to Professor S.K. Gupta for sharing his video message and bless us for successful organization of this event. My warm gratitude goes to Professor Jorhat for his presence and his guidance. We are extremely thankful to Professor P.P. Asajja and Dr. Avik Paul from Techno India College of Engineering, IFRA, for visiting us on this auspicious day and signing an MOU with us for scientific cooperation. May I take this opportunity to thank and acknowledge the students and faculty representatives from several reputed institutions, namely Dr. Vinita Pathak and group of students from Tribhuvan University, Dr. Madhurya Deka and group of students from Kaziranga University, Dr. J. Soikia, Mr. M. Kakoti, Mr. P. Bora, and group of students from JB College, Dr. D. Soikia, Principal of Christian Academy and students, Ms. Sarmista Datta and group of students from Whip Valley Academy, Mr. P. Raskwa and Mr. Siranjit Hazarika and students from Morini College, Dr. Bandana Sinha from Neho Ceylon, students from Royal Global University, Guwahati. I would also like to thank all the members of Geoscience and Technology Division, including head Dr. Manoj K. Fukan, for being the backbone of this entire event. A few special mentions in this regard are Shostov, Chinmoy, Sandram, Dr. Gautam, Dr. Timangsu, Prasidjo, Navajyoti, Onesa, and Sujit. I am also thankful to Dr. Pawan K. Bora, retired chief scientist, for his presence. Last but not the least, I would also like to thank all the staffs of administration, guest house, director secretary, electrical section, refrigeration, floriculture, civil engineering for their helping hand in organizing this event. My esteemed respect and appreciation goes out to each and every one of us present here today to join this meeting. A light refreshment is arranged outside this auditorium, and I request all of you to join us. Thank you once again.